Hey students, now we are going to put together working with angles as far as triangles and parallel lines. So this will be a not so very quick, however I'll try to be as fast as I can. So if you need to pause this at any time, just pause it so you can think about what I just said or rewind it because I'm going to try to go really fast. Here we go. All right, so here's an example. Question number 1 says lines AB and CD are parallel if the measure of angle 6 is 32 degrees. So I will write that in there, right there. What is the measure of angle 7? Well, guess what? Angle 6 and angle 7 are vertical angles. And we know that the measure of vertical angles are equal. So therefore, the measure of angle 7 is equal to 32 degrees. All right, that was like 26 seconds. So let's move on to the next problem. Okay, in this problem, it says, this looks like a lot of fun, by the way, triangle QRS, so that would be this one, is isosceles with QR congruent to SR. By the way, that's how we say that two lines are congruent. We just put a little dash in them so that we know that they are the same. The measure of angle SPQ, so that's up here, is 33 degrees. And the measure of angle QRS, so that's down at the bottom, is 32 degrees. Our goal is to find the measure of angle PQR. So if I'm looking ahead, I believe at the top I need to figure out this angle. And at the bottom, I need to figure out this angle, and then I can add them together. So let's just take a look at the top triangle. I see it's a right triangle, and I know that the sum of the angles in any triangle is always 180. So if I start with 180, and I subtract 90, and then I subtract 33, that should give me my final answer. So 180 minus 33 minus 90 is equal to 57 degrees. So that tells me this angle right here is 57 degrees. Now I need to look at the bottom triangle. It's an isosceles triangle, and I know that third angle. So one thing, I'm not sure if you know this or not, but if these two sides right here are equal, then their opposite angles are also equal. So in any isosceles triangle, two sides are equal and two angles are equal. So I'm going to write an equation just because I love equations. I know that 32 degrees plus, let's call these angles x. I know that they're the same. Looks like a little face. I know that they're the same, but I don't know what they are. So there's two of them. And if I add those three angles, I get 180 degrees. So let's just solve this little equation here. I'm going to subtract 32 from both sides. I apologize for my sloppiness, but I'm trying to go really fast. That is going to leave me with 2x equals 148. Now I'm going to divide both sides by 2, and that leaves me with x is equal to 74. So I know now that this angle right here is 74 degrees. So angle PQR, that big angle there, must be the sum. So I'm going to add 57 plus 74, and that gives me 131 degrees, which should be that answer. Okay? All right, I am moving really fast. Feel free to check my answers because I might be wrong. Believe it or not, I have been known to make mistakes. So please feel free to check my answers, and if you find me wrong, nice job for you, bad job for me, but I owe you, so please come let me know. All right, let's move. This one also looks like a lot of fun, but I'll tell you what, it's really not that bad. Okay, we have that the measure of angle JSR, that's right up here, is 55 degrees. And we know that the measure of angle SLN, that's right here, is 79 degrees. And we need to figure out what the measure of angle LNS is. So we need this one down here. Well, check it out. The measure of JSR is 55, and this one here is a vertical angle to that. So I know that is also 55 degrees. And so if I'm trying to find this angle down at the bottom here, I'm just going to, I'm going to start with 180 because that's the sum of three angles in any triangle. Subtract 55, subtract 79, And if I do that, that is going to give me 46 degrees. And ladies and gentlemen, that is my answer. That really wasn't too bad. Let's move on. Please feel free to pause this and rewind as you feel needed. Okay, so for this last question, there's a bunch of things that you are going to need to make sure you know about it in order to find it. Actually, only two. In the triangle, we know that the triangle is an equilateral triangle. That's very important. And we know that the quadrilateral is a square. That is also very important. It tells us information without us them actually giving us numbers. Okay, in an equilateral triangle, all the sides are equal. However, all the angles are also equal. So if all the angles are 180, and there's 3 of them that are equal, that means in every equilateral triangle, every angle is always 60 degrees. So right here, this is 60 degrees. And then in a square, this angle right here, every angle is 90 degrees because they form right angles, so I know that this is 90 degrees. Now, I actually didn't read to you guys what we were supposed to find. The question is saying, what is the measure of angle ABD? So ABD is right here in the middle of them. Notice those 3 angles form a straight line. And a straight line always adds up to 180 degrees. So I'm just going to again start with 180, subtract 60, and subtract 90. And when I do that, I am going to get 30 degrees, and that is my answer. Now, if I wanted to use algebra, I could have done something like 60 plus x plus 90 equals 180, and then you could solve it from there. That's still going to give me 30 degrees. Okay, one more question. I think I'm going pretty good, so let's move on. All right, last question. It says in the figure below, triangle PQR is an isosceles triangle with PR equal or congruent to QR. And the measure of angle PQR is 38 degrees. Okay? We talked before, so right away what I know is that this angle and this angle must be congruent. Their measures are equal since opposite sides are equal. Okay, so if this side is equal to this side, their opposite angles are also equal. So therefore, I know that angle QPR is also 38 degrees. And my final question is, what is the measure of angle QRS? So QRS is right there. I am going to do it a long way, and then I'm going to show you somewhat of a shortcut. All right, so first of all, let's find the measure of the last angle in that triangle. And so again, the sum of the angles in every triangle is 180. So I can do 180 minus 38 and minus 38 again, and I will get 76 degrees. No, I will not. I will get 104 degrees. If I added these to the two sides here, you get 76. Subtract from 180, you would get 104. So this angle down here is 104 degrees. Now I need the measure of angle QRS, and those two angles form a straight line, so they're supplementary or they add to 180. So now I'm going to take 180 and subtract 104. And my final answer there is 76 degrees. So what I wanted you to see is that 76 came up a lot. There is this theorem, now you're not in a geometry class in high school, but there is this theorem that says if you have an exterior angle, so check out this triangle, this side of the triangle is extended, right? And that has two angles here. We've got an inside angle and we've got an exterior angle. So every exterior angle of a triangle, sorry about my handwriting, that should say angle. Every exterior angle of a triangle is equal to the sum of the other two angles. Now we could go through and prove this to you, but I wanted to keep this short. So notice 38 plus 38 is 76. And when I subtracted that from 180, I got 104. And then to get that exterior angle, I would just take 180 and subtract 104 and end up with 76 again. So as a little shortcut, if you remember, if you have something that looks like an exterior angle of a triangle and you know the two opposite angles in the triangle, you could just add them together. or do it the long way. All right, hopefully this helped you. Go back and review anything that you didn't understand since I talked really, really fast. Peace out.